If you are building a decentralized application, you probably need to accept some payment. And for that, you need a currency. The problem with Ether is that it's way too volatile. Fortunately, we have an alternative with the Dai stablecoin. So Dai is a token on the Ethereum blockchain that always keep the same value. Here on this chart, you can see that there are some small fluctuations, but these are quickly corrected. However, the Dai ecosystem is quite complex. But you don't need to actually dig into this, and there is an easy way to integrate Dai in your DeFi project. So in this video, I'm going to show you how you can transfer Dai from Solidity and also from outside the blockchain using Web3. Hey, I'm Julian, and on my channel EatTheBlocks, I teach blockchain development and how to become a blockchain developer. There are different kind of people that interact with the Dai system. So first you have end users, so people like you and me who have Dai token and who want to do certain operation with the token. Then you have smart contract and DeFi projects. Then you have what we call keepers, so they are there to ensure the stability of the token. And I'll explain this just after. And then you have MKR token holders. So actually there are two tokens in the system of Dai. You have the Dai token itself, and you have another token that is called MKR, and that is here for governance. What is very important to understand is that the only people that really need a deep knowledge of the Dai ecosystem are the keeper and the owner of MKR tokens. If you are an end user or you're building a DeFi project that interact with Dai, you only need to understand how to interact with the Dai token. So this is a very simple representation of what happened when we create a new Dai token. So first you have a user that wants to create a new Dai token. So that user is going to send some Ether to the Dai factory smart contract. So the Ether is going to be locked, and after that the Dai factory contract is going to create a token by calling the smart contract of the Dai token. So that's another smart contract, and this new Dai token will be sent to the user. The user has actually a debt in Dai. At any time the user can get back his collateral, but for that he has to give back the Dai tokens. At any time, if the value of the Ether collateral falls below 150% of the value of Dai token that were created, then a process of liquidation is going to happen. So in this process of liquidation, the Dai debt of the user will be cancelled, but the Ether collateral is going to be sold to cover for the Dai token that were already created. And if there is any remainder, it's going to be sent back to the user. Because this is impossible to have a smart contract auto-execute in the future, in order for this liquidation process to work, we need to have users who continually monitor the value of Ether and who activate a certain function in the Dai smart contract. This is the role of keepers. And for this to work, we also need to have a smart contract oracle on the blockchain who report the price of Ether. Another important thing to note is that the liquidation process only affects people who created a Dai position by creating a Dai debt and sending some Ether. But if you buy Dai, for example, at some decentralized exchange, you don't have to worry about liquidation. If you do some research about Dai, there is a caveat. Actually, there are two versions of Dai. Single-Collateral Dai, also referred to as V1 sometime, and Multi-Collateral Dai. So with Single-Collateral Dai, the only collateral acceptable was Ether. But with Multi-Collateral Dai, any Ethereum token can be used as a collateral as long as it has been approved by the community of Dai. So the old Dai token has been renamed to Sai, and the new Dai token is just called Dai. Another change introduced by Multi-Collateral Dai was that from now on, there is something called the daily saving rate, or DSR, so anybody who holds some Dai is entitled to receive some interest. So be careful whenever you check some documentation or you check some info on Etherscan. You want to use the latest version of Dai, which is just referred as Dai, not Sai. So now let's focus on the Dai token. So this smart contract is responsible for managing the ownership of Dai token and also transfers. This is an ERC20 token, so it respects all the standard interface of ERC20. If you don't know what is an ERC20 token, check out this video. So here, this is the official documentation of the Dai token in the GitHub repo of Dai. So if you scroll down, so here it tells you the basic, like for example, here it's always pegged to $1. Let's scroll down, then it gives you the addresses of the token on the mainnet and also on the Kovan testnet. Then it also gives you a couple of info for the metadata of the token, the symbol, the name, and a number of decimals. I will explain the decimals after. Then you can have some info on, you can have some statistics on the token here. So you can see Dai stats, for example. So you can see the total number of Dai, size. So this is the old version of the Dai token. So let's scroll down. And here it talks of the smart contract. And he mentioned this thing, the DS token. So DS token is an implementation of ERC20 that uses the DAppSys framework. So DAppSys is a framework for Solidity smart contract. And if you keep scrolling down, that will give you some instruction to manipulate this DS token using this DAppSys framework. So you will need to install the CLI of DAppSys framework in order to execute this. But I don't really recommend to spend too much time learning this framework because this is nowhere as popular as Truffle, and I don't find it so intuitive. So the most important thing to understand is that this token is an ERC20 token. So we can use any implementation of ERC20 token and it should allow us to represent this token as well. So in the coding section just after that, instead of using the S token and DAppSys, we're going to use the ERC20 implementation of OpenZeppelin, and for the smart contract framework, we're going to use Truffle. Next, I'm going to show you how you can transfer Dai from Solidity. So for that, you will need to have installed on your computer Node.js as well as NPM. So visit the website of Node.js if you don't have it on your computer. You will also need to have installed Truffle. So you can install Truffle like this. This is the most used framework for Solidity smart contract. And after that, you can use the Truffle CLI. So we're going to create a Truffle project with the Truffle init command. And then you should see all these files in your folder. So we're going to work mainly in the contracts folder, but first we need to install an npm dependency. So we need to use the ERC20 contract of OpenZeppelin. So OpenZeppelin is a library for Solidity that has a lot of common token implementation. So to model the Dai token, we need the ERC20. So we're going to install OpenZeppelin like this. Oops, I forgot to init the project with npm first, so you should init it first like this, npm-y. All right, let me reinstall OpenZeppelin, and this time it's going to save it into package.json. Yes, so we have it here. Okay, cool. So next we're going to create a couple of smart contracts inside the contract directory. So first we need to create a mock for the Dai token. So in programming, a mock represents some other entity that usually we can access during development, but we still need to interact with this entity. So for example, we use mock a lot when we want to interact with some API, but when we are doing local development, we can't always hit this API. So here, since we are working on a local development blockchain with Truffle, we can interact with the real smart contract of Dai on mainnet or even on a public testnet. So we need to mock this token locally. So we're going to do this. So in contract, we're going to create a smart contract that we're going to call Dai.sol. All right, so let's open this up. So here we're going to create an ERC20 token that will represent the Dai token. So we start with the usual pragma statement of Solidity, and after we need to import the ERC20 token of OpenZeppelin. So let's have a look in the GitHub repo of OpenZeppelin because I don't remember by heart the token we need. So we'll go inside the contracts folder, then we have a token folder here, then ERC20, and the one we want is ERC20 detailed here, so it has some metadata about the token, and it has a constructor where you have to give it the name, the symbol, and the number of decimals of the token. Okay, and the path is this thing here. All right, so let's copy paste this. So we need to import from open Zeppelin, then /contract, then you give it the full path. We also need to import the base contract of ERC20. So that's just ERC20 like this. Okay. And then we're going to create our Dai token like this. So it's going to inherit from ERC20 and ERC20 detailed. And after that, we're going to create a constructor, and it's going to call the constructor of ERC20 detail. So we need to provide the name, the symbol, and a number of decimals. So how can we know what are the correct value? Well, for that, we're going to etherscan.io, which is a famous blockchain explorer for Ethereum. So that will allow you to inspect some smart contract. And here we're going to search for the Dai token. So we type Dai stablecoin. Okay, so that's should be this one. Okay, so let's scroll down, and here you can find this menu here, read contract. So let's click on that, and with read contract we can read some info from the smart contract. So we're gonna find the name here. So the name is Dai stablecoin. So let's paste this. Then the symbol should be, oh yeah, so we have a number of decimal here, 18. So that's the third argument here. And for the symbol here is DAI uppercase. Okay, so DAI. All right, so with that we have our mock token. So now we need to deploy it in a migration folder. So migrations, and I'm going to call this deploy contracts.sol. Here I never remember by heart what we need to put here, so I basically always copy paste from the initial migration that is provided by Truffle. That is just some, this contract is a contract used internally by Truffle, so you can just ignore it, but the fact is you can just copy this. Oh, and I call this file.sol, but it should be .js. Oh, my bad. That's a typical mistake I sometimes do. So let's rename this. It should be .js. Okay. So now let's rename everything. So migration should be renamed to Dai token, not just Dai. All right. So with this, I'm going to try to deploy this. So in another terminal, I'm going to launch Truffle develop. Right, let's try to deploy it, migrate, reset, just to make sure there is no mistake. And yes, it's working. Okay, so now back to our code. So now I'm going to create another smart contract that's going to represent our DeFi project. So this DeFi project smart contract is going to call the Dai contract to do some operation like transferring token. So let's create our smart contract, and I'm going to call it my DeFi project.sol. Okay, pragma solidity 0.5.0 contract my DeFi project. So first we're gonna need to inject the address of Dai inside our contract. So for that we're gonna do this in the constructor. So address and here it's going to be Dai address, and then we're going to store this address somehow. Store address, but before, so we need to import the interface of ERC20 token. So let's do this. Open Zeppelin contracts, and then should be token, and then I believe it's ERC20, and then ERC20.sol. You know what? Let's check on the repo of Open Zeppelin. So ERC20, and here ERC20. Okay, so this is the correct path. Let's copy this. Okay, do I have the correct one? Contract token. Yes, this is correct. Okay. So now in my constructor, I'm going to create a pointer to the Dai token, and we pass it the address like this, and we're gonna store this into a state variable called Dai. So we're gonna define this variable before. So the type of this variable is of the interface of ERC20. All right. So with that, after the smart contract is deployed, and we can use this Dai variable to interact with our Dai smart contract. So for example, if we create another function, foo, and so in this function foo, we're going to do some stuff, and after that, at some point, we want to do a transfer of Dai. So we're going to do something like this. So Dai, so for example, transfer. So we specify the address of the recipient and the amount. So for example, MSG sender, and here transfer 100 elementary unit of Dai. So here it's important to understand that this doesn't mean that we're going to transfer 100 Dai, because Dai works exactly like Ether, so it has 18 decimal. So if you wanted to actually transfer a full Dai, then that means that that's 1 with 18 0 after. So 1 2 3 1 2 3 etc. But otherwise, if you don't do this, if you just do like 100 like I did here, it's like 100 cents of Dai. So that's a very, very small unit. So in any case, with this line here, we're going to transfer 100 cents of Dai to the address that called our foo function. And if you want to do a dedicated transfer, then we will use the transfer from function. So as specified in the ERC20 standard. All right. Next, we're going to deploy our smart contract and make sure that when we call the foo function, the Dai transfer actually works. So we're going to go to our migration file, and we're going to import our smart contract, my DeFi project. So when we deploy my DeFi project, we need to pass it the address of Dai. So that means we need to wait for Dai to be deployed. So here we're gonna make this an async function so that we can use the await keyword. And here we're gonna get a pointer to the deploy instance of Dai. And after that, we're gonna deploy our smart contract and pass the address of Dai. So we can pass an argument to the constructor like this, Dai.address. All right, so let's save this. So let's go back to our Truffle console and make sure that everything works fine. Okay, it's working fine. Next, we're gonna get a pointer to our project, to our smart contract, my DeFi project. And after that, we're going to call our foo function and see what's going to happen. So let's go back to Truffle console, migrate, and boom, we have an error. Oh no, what happened? The problem is that the sending address doesn't have any Dai token. So we need to give it some Dai before we execute all of this. And for that, we need to use the concept of Faucet. So if you use some public testnet before, like Robston or Kovan, you probably use this already. If not, basically a Faucet is a way to get some free token. So since we are creating a mock for the Dai smart contract, then we can very easily create a function for that. So go back to your Dai smart contract. You're going to create a function called Faucet. It's going to accept two arguments. First, the recipient of the token, and then the amount of token that we want to create. And after that, we're going to use the min function provided by the ERC20 implementation of Truffle that we inherit here. So we have access to this function, underscore mint. First, it takes the recipient address and then the amount. And this is going to create this amount of token for this address. Very simple. Actually, I like to revisit also the foo function for my DeFi project because I want it to be a bit more flexible. So same thing here, recipient and amount, and we're just going to forward this to this function. Okay, and now we're going in the migration file. And before we call the foo function, first we're gonna call the Faucet. So await Dai Faucet. So the recipient should be the smart my DeFi project smart contract, and we want to create 100 token. Okay, and after in the foo function, so the recipient should be another address. So for example, the second address generated by Ganache. If you don't know what is Ganache, it's a local development blockchain, and that is what is used behind the hood by Truffle. We're going to send 100 token to this address. Oh yeah, I forgot to mention. So actually I've added also these two arguments here to the callback, so network can ignore it, but accounts, this is the list of addresses generated by Ganache. So we need it because here we reference it. Okay, so we generate the Faucet, we send it to our smart contract, then we call the foo function of the smart contract, which is going to transfer 100 cents of Dai to this address. And finally, I like to check the Dai balance for both here the smart contract and this address to make sure that everything is correct. So let's do this. Balance equal. So here we execute the balance of function of the Dai token, because this is an ERC20 token, so we also have access to this function. So we want the balance of this address, and after we also want the balance of this address. The first one should be 0 because it sent the token already, and the second one should be 100. Okay, should be fine. So now let's go back to the Truffle console. And yes, it has worked. Here we can see that first balance has 0 and the second address has 100 Dai. Yeah. So all of this is cool, but we are just dealing with a mock Dai token in on our local development blockchain. But how could we interact with the real Dai token on a mainnet, or at least on a public testnet? So I'll explain you the process for testnet, and for mainnet this is almost exactly the same thing. So the Dai token is deployed on the Kovan testnet. So you cannot use your mock Dai token, you have to use their version of the Dai token, which is already deployed. So I'm going to describe all the steps you need to do. So first, you're going to use the Kovan Faucet to get some Kovan Ether. to any address you want. So with this address, you're going to get some Dai using the Oasis interface of MakerDAO. So basically, you're going to send your Kovan Ether and they're going to send you some Kovan Dai. Then in your migration script, you're going to deploy your smart contracts. So that's basically what I call my DeFi project in my example. So this time you will need the address of the Dai token already deployed on Kovan. You can find this at this URL and that is regularly updated. Then you're gonna send this smart contract some Dai from the address that received it before. Then you can execute the foo function of your smart contract and it's going to work. And of course, you also have to modify your migration script for deploying to Kovan. So that means probably using a service like Infura. You also need to probably use the NPM dependency HD wallet provider to manage your private key inside your truffle config. And if you don't know how to do this, you can check out one of the links in the description, point to a video where I explain this. So far I show you how to interact with the Dai token using Solidity in a smart contract, but sometimes we want to interact with Dai from outside the blockchain, from the front end of a decentralized application using Web3. So let's see an example of that. So I'm not going to create a full front-end application to show you this, but I'm going to create a script file with the code for Web3. And after you can copy paste this Web3 code into your front-end. So let's create this script, script.js. So first you need to instantiate Web3. So it's going to be something like this. New Web3, and then the link, the URL to your Ganache instance. So often it's going to be localhost 9545. Then once you have this, you're going to get the list of addresses like this. Then you're going to get a Web3 contract instance. Here you'll pass the ABI after the address of the contract. And after that, you'll be able to interact directly with the Dai token like this. So for example, if you want to transfer some token, it's going to be dai.methods.transfer. Then you're going to pass the recipient, the amount, and here the from address. So of course, in your code, you need to replace the different variables like the ABI, the address, recipient, amount, and from address. This way of interacting with the Dai token is very low level and simple, but if you want to have more sophisticated interaction with the Dai ecosystem, actually, I recommend to check out the official JavaScript client of Dai. So that's an NPM package that is called MakerDAO/Dai. And so here you have a good documentation on the NPM homepage and with some example. But one thing that I found lacking is that here on the homepage, they don't explain how to connect to a specific network. So actually you need to go to the wiki for that. Next in this series on DeFi programming, I'm going to show you how to interact with Uniswap, a decentralized exchange for ERC20 token. I'll see you there.